Hello everybody, welcome again to another set of videos where we're dealing with topics in mathematics. This is the first of 4 videos where we will be treating specifically with the topic of simultaneous equations. Right? As most people who do maths at any level would know, simultaneous equations is one of those topics that causes some level of consternation to a lot of people. So in the first 2 videos we will treat with what I would consider level 1 simultaneous equations, and we'll go into that a little later. In the second 2 videos, however, we will deal with a slightly more complicated situation, but I will be introducing a method to solve the equations that will be a little different perhaps than what people will be accustomed to being taught in schools and in most textbooks. But it is a very effective method, one that I believe will be of great assistance to most people. Alright, so let us get on with the show. So we have an equation on the board here. X plus 2y is equal to minus 4. 3x minus y is equal to 9. Good? So you have 2 variables that you're looking to find. 2 unknowns, as we call them in maths. The unknowns would be x and y. Now, in your general equations where you have just one equation, you would have one variable that you're trying to find. If you're trying to find 2 variables, then you would need 2 equations. If you want to find 3 variables, as in x, y, and z, you would need 3 equations. If you want to find 4 variables, you need 4 equations, etc., etc., etc. Needless to say, the more unknown variables you're trying to find, the more complex the situation will get mathematically. Alright, so the 3 and the 4, etc., that is for other times, other places, but for now we're dealing with 2. Now, these are what we call linear equations. Linear, just to be simple here, we don't have any terms in square terms like x squared or y squared or anything like that, right? You have x and you have y with a coefficient in front of each. The coefficient simply being the constant that you're multiplying each variable by. Good? So a little talking just to start off, but once we start, we go in. So, right, so you have the 2 equations here. Now, if you notice, you have x here, and you have minus y here. Good? So that's the first thing I want to encourage you. When you have 2 equations to deal with, first thing you need to check for is to see if you have what I would call a single coefficient. It is either 1x or minus 1x or 1y or minus 1y. If you have such a situation, then you're good to go, because the situation is a little more straightforward than if you have a pair of equations where you don't have a single coefficient. But we will deal with those in videos 3 and 4. So the first 2 videos we're dealing specifically with single coefficient situations. Good? So in this case, we will focus on the x variable and use that as a means of finding all the values, the x and the y. So what do? We look at equation 1 and we do what we refer to in algebra as making x the subject of the formula. Alright? So which is another way of saying we're solving for x. So from this equation, we take the plus 2y on the left side here and we carry it across on the right. So that from equation 1, you get that x is equal to minus 4 minus 2y. Which we will then take and substitute into equation 2. So having found x equal minus 4 minus 2y from equation 1, we then take that and substitute it here into equation 2. So we now have 3 into x, which we already agreed was minus 4 minus 2y. 3 into minus 4 minus 2y minus y is equal to 9. So what we have now is an equation, a linear equation, in one variable alone. So in other words, when we have 2 variables, we have to deal with one variable at a time. So even though the name of the topic is simultaneous equations, the only thing that is simultaneous is the fact that they have 2 equations at the same time. Right? The solution is not going to be simultaneous. The solution is going to be sequential, meaning that you find one variable first and then you use that value to find the value of the other variable. So having taken x and expressed it using equation 1, we now substitute it into equation 2, and we have now an equation wholly in terms of the y variable. So 3 by minus 4 is minus 12. 3 by minus 2 is minus 6y. That is what we get when we expand here. So minus 12 minus 6y minus y is equal to 9. And then we bring all the like terms together. So if we have minus 6y and minus y on this side of the equation, then we could take the minus 12 from over here and carry it across here to get plus 12. So we now have minus 6y minus y, which is equal to 9 plus 12. Good? Minus 6y minus y is equal to minus 7y. 9 plus 12 is still 21. So y would be 21 divided by minus 7, which is equal to minus 3. So when we substitute now that we have y equal to minus 3, we take this value and substitute it back into equation 1. Now the truth is that you could substitute it back into either of equations 1 or 2. Alright, so for the purposes of this video, we substitute y equal minus 3 back into equation 1. If you like, you could substitute it back into equation 2 as well. Work it out and verify that the answer will still be x equal 2. Good? These little things are always good to do, to play with it a little bit on your own. Because when you play with it on your own, you get to understand that there are many ways to work this thing out. Right? You don't have to fix yourself to one way that one teacher show you or that you see in one textbook. There are many ways to do these things, and the more you understand that, you can develop your confidence, you can develop your conviction in dealing with the topic. So we're going again. Substitution. X plus 2 into minus 3 equal to minus 4, which is taken from this here. X plus 2 by whatever the value of y is. So x plus 2 into minus 3 is equal to minus 4. X plus 2 by minus 3 is minus 6. So x minus 6 is equal to minus 4, which is to say then that x is equal to minus 4 plus 6, which is still 2, so that your x is equal to 2 and your y is equal to minus 3. Alright, so that is the first method that we use to solve this particular pair of simultaneous equations. In the next video coming up after this, we will pivot on the y variable, meaning we will take y from equation 2, make it the subject of the formula, and then substitute it back into equation 1 or 2 to find, substitute it back into equation 1, Take y from equation 2, express it, then substitute it back into equation 1, which would give us our equation wholly in terms of x. And then having found the x value from here, we could then substitute it back into equations 1 or 2 to find the y variable. Alright? Now, if you find we're going a little too fast, you always have the option to slow down. You could pause and listen. I want to encourage you all strongly. With these things, you have to really give it your full attention. This is not something to look at in a rushed manner. Yes, you could watch it on YouTube on the bus going home, but at some point you'll have to sit down and go through the question, pen and paper. You have to practice. So even if you look at the video and you understand it, you have to practice, which means finding questions similar to what we do here. Practice to get it done, so that whenever you find yourself in a pressurized situation, right, such as an exam, you can reproduce and get the answer properly. Okay, so look out for video 2 coming up shortly.